All right, hello everyone. Today we're going to take a look at something really fundamental, how we can use the Boolean logic you already know, your ands, ors, and nots, and put it to work inside programs to help them make decisions.
Now, the most important thing to remember is this. You are not learning new logic today. You've already got the core skills down. We're just going to apply that knowledge in a new place, which is inside a program's conditional statements.
So, here's our plan. We'll start with a quick recap. Then look at how code uses true and false to decide things. We'll see our key operators in action, explore how brackets control the flow of logic, and then, and this is a big one, we'll learn how to spot a common logical mistake.
Okay, let's kick things off with a simple scenario to get our heads in the right space. Imagine a rule for submitting homework online. A student can submit their work if they are logged in and the deadline has not passed. Now, for that submission to actually go through, both of those things have to be true. If the student isn't logged in, that's false. If the deadline has passed, that's also false. If either part is false, the whole statement becomes false and the submission gets blocked. It's this exact all-or-nothing logic that programs follow.
So, that brings us right to our next point. How do programs actually use these true or false values to make choices? Well, here's the golden rule. Every single time a program checks a condition, it's really just asking a question. And the answer to that question can only ever be one of two things. It's either true or it's false. There are no maybes, no in-betweens. Let's look at this in the OCR reference language. First, we've got a variable, logged in, and we're setting it to the value true. Then, the program gets to this if statement. It checks the condition. Is the value of logged in equal to true? Well, yes it is. The answer is true. And because that result is true, the program follows the instruction inside the if block and prints access allowed.
Simple checks are great, but things get really powerful when we start combining conditions using the logical operators you already know, and, or, and not. These are the tools we use to build much smarter, more complex decisions into our code.
Let's compare and or side by side. The version with and is much stricter. For that allowed message to appear, both A and B have to be true. No exceptions. But look at the or version. It's way more permissive, more relaxed. It only needs one of them to be true. If A is true, that's enough. If B is true, that's also enough. That difference between strict and permissive is absolutely key. And then we have the not operator. Its job is incredibly simple but so powerful. It just takes the result of a condition and flips it. If a condition was true, not turns it into false. And if it was false, not makes it true. But you have to be careful, because where you put the not operator changes everything. On the left, the not only applies to the result of A equals true. So if A is true, the not flips that to false. But on the right, see the brackets? That means we have to work out the entire A and B condition first. Then the not flips the final result of that whole expression. Placement is everything. You know, that leads us perfectly into the role of brackets themselves. Just like in maths, when you use brackets in your code, you're telling the computer what to do first. The part inside the brackets always gets sorted out before anything else.
Take a look at these two. They use the exact same inputs and operators, but those brackets make them behave completely differently. In condition 1, the A and B part is dealt with first, then its result is checked with C using OR. This means that if C is true, the whole thing is true and we don't even care about A and B. But in condition 2, the B or C is evaluated first. Then that result is combined with A using AND. In this case, A absolutely must be true for the condition to pass. The logic is totally different just by moving the brackets.
Now, a really great way to see this flow of logic is to use logic gate diagrams. They show the exact same ideas we've been talking about, just in a more visual, graphical way. And you'll probably recognize these straight away. We have the symbol for the AND gate, the OR gate, and the NOT gate. These are our visual building blocks. Here's the connection that ties it all together. The job that brackets do in our code, forcing one part to be calculated first, is handled by the way we connect the gates in a diagram. The wiring dictates the order of operations. So for instance, if we have inputs A and B going into an AND gate, and then the output from that gate becomes an input for an OR gate along with C, well, that diagram visually represents the expression A and B or C. The structure of the diagram makes it obvious that A and B get processed together first before their result is combined with C. Okay, let's move on to something that's a really crucial skill both for debugging your own code and for your exams. We're going to look at situations where a piece of code looks perfectly fine, the syntax is correct, but the logic is completely wrong. Take a look at this line of code.
The programmer here probably wanted to allow access to anyone aged between 12 and 16. That seems to be the intention, but there's a big problem with the logic.
So what does this condition actually do? Let's test it. Pick an age, say 25. Is 25 greater than or equal to 12? Yes, it is. That's true. Because this is an OR condition, we don't even have to look at the second part. The whole thing is true. Okay, let's try an age like 10. Is 10 greater than or equal to 12? No, that's false. But is it less than or equal to 16? Yes, it is. That's true. So again, the whole condition is true. In fact, this condition will be true for any age you can think of because every number in existence is either 12 or over or 16 or under. The logic is completely flawed.
If you're asked to explain this kind of thing in an exam, here's the perfect three-step framework. First, explain why it's wrong using the words true and false. Second, give some specific examples of inputs that show the problem. And third, suggest how to fix it. In our case, the fix would be to change the OR to an AND, so the condition becomes if age greater than 12 and age less than 16. So as one last check on that idea of evaluation order, just think for a second about the difference between A or B and C versus A or B and C. In that first one, C must always be true along with either A or B. But in the second one, if A is true, it passes right away. But if A is false, then both B and C must be true. See? The order completely changes the rules of the game.
Okay, let's wrap up with the key takeaways. The rules of logic are the same everywhere, whether you're just describing something in English, drawing a logic diagram, or writing code. Being able to follow that flow of true and false values is absolutely essential for finding and fixing bugs. And honestly, getting this right now is going to make more complex programming challenges so much easier down the line.
Being able to read a condition and figure out what it does is the first half of the battle. The next step is writing them correctly yourself from the very start. So the question I'll leave you with is this. Now that you can trace and debug this logic, how is that going to change the way you write your own conditions?